Okay, everyone, thank you so much for your kind attention. This is my homework number three, number 5, with the topic of servo motor. And this is come from C# book example 4.4 with the title of Control RC Servo from Graphical User Interface of Visual Studio. The hardware, I will use Arduino Uno and Micro Servo SG90. And this is the software that I use, Microsoft Visual Studio for the GUI and Arduino IDE version 2.3.4. This is the version with the dependencies of Servo.h by Michael Margolis and Arduino team. The version of the libraries is 1.2.2. Before I continue to the wiring diagram, I will tell you about a little bit theory about servo motor. I will explain about servo motor. Servo motor or servo refers to any closed-loop control system that operates using negative feedback. An example of a servo system is the cruise control in a car, which monitors the vehicle's speed and uses that feedback in a control circuit to adjust the accelerator, ensuring a consistent speed. In the case of RC Servo, the output shaft position is continuously measured and fed back to an internal control circuit. The circuit adjusts the motor's current to maintain the desired position. This is some servo motor example. The price is from $9, $11, $12 like that, up to $42 or $43. The the type or the mark, can be high tech like that, and also this one is high tech, all of it is high tech. This one is parallax, and the price ranging also from $40 like that. We have some some example for servos, the types, the color, something like that. And what is a closed loop in the servo motor? Servo motor are sophisticated device that control their movement with pinpoint accuracy. So it means that the accuracy is so good. They work on the principle of a closed loop system, meaning they constantly monitor their position and adjust accordingly. As you can see, this is the industrial servo motor with this one encoder, and this is the generic servo motor. And the sensor we have here is potentiometer. So the position sensor in here can be encoded for industrial motor or potentiometer in the generic or hobby servo motors. As like this, as I mentioned before, for the industrial, yeah, we utilize high precision encoders to track position, and for RC car, something like that, we employ only potentiometer. And the control loop is the motor actual position is measured by the sensor. This information is compared to the desired position, and any difference or error is detected. The motor is then adjusted by the controller to minimize this error and achieve the target position. This is inside the servo motor. There is a gearbox like this with high torque, but the the RPM is so slow, and there is a potentiometer to serve as a position sensor. This is the central control circuit, and this is the DC motor with high speed and low torque. Okay, this is the real breakdown of servo motor. This is the as we usually use DC motor. This is the position potentiometer, and this is the circuitry with a small microcontroller on a specialized servo IC. This is the gearbox. And this is the color scheme. As I said before, this is we can see that the color is mostly black, red, yellow, but this one is different. Black, red, white maybe. Okay, so this is the color scheme. This is the table below provide a summary of common color scheme encountered in electronics. This is for a mnemonic easy to remember. This color code associated darkest color, usually black or brown, is usually connected to ground, and while red is usually connected to power. Okay, this is Futaba. If Futaba, we can black, red, white. If from GR, brown, red, orange. If high tech, we can have either black for ground, and for power we can red or brown, and control signal we can see yellow or white. And for the we can see that what we need to consider, and if we want to connect to servo motor, we need to always refer to the datasheet. Achtung, achtung. Okay, there are two types of servo rotation. The standard rotation, we can see that it almost it more than 180 degrees, but it's not more than 270 degrees. And this is the first type, and the other type is continuous rotation. It can move continuously like that, and can have the we can still have the desired position. And a little bit theory about PWM, or pulse width modulation. PWM is a cool term to represent a type of digital signal. PWM can be generated using a simple IC like NE555. It can also produce from a microcontroller output, Arduino development board, for example, or using AFG function generator. Duty cycle states that the ratio between on time and the total period on time and off time. That's duty cycle. So for this example, this one is 25% duty cycle. This one, because the high logic and the off one, this is the on time, this is the off time is same. So this is 50% duty cycle. Duty cycle is usually expressed in the percentage. And for the servo motor, we can see in here, if the on time is only 1 millisecond or 0.5 millisecond, the servo will move to 0 degrees. Okay, this is 20 millisecond or 50 hertz. And if we want to move the servo motor to the 90 degrees, the on time should be set into 5.5 millisecond with the same period of time, 20 millisecond. If we want to move the servo to 180 degrees, we should set the on time to 2 millisecond or 2.5 millisecond. According to the datasheet, we should refer to the datasheet. So this is a little bit theory about the servo motor. And because we will use the Arduino, not all pin of Arduino can be connected to servo to control the servo motor. So it should be in some of these pins. The pins that has infinity symbol like this one, pin 3, 5, 6, 9, 10, 11. Okay, that's from a little bit introduction about servo motor. Thank you so much. Okay, this is the wiring diagram I will show you in the Proteus. This is the servo. This is the Arduino development board minimum system, and this is the servo. The servo is uh, the servo is connected to pin 9. And this is the GUI, the design of the GUI. This is the color, the comfort, and yeah, I have 3 buttons. Connect. Uh, to connect, it will open the serial port, and turn servo right will make the serial port send the 1, and this one turn left will send 0. So it will be catched as by the servo code in C++ or Arduino code. If the serial read is 1, so it will make the servo rotate in counterclockwise. Oh, right, 90, 120, 180. And if case 0, it will in the different direction. Okay, that's the code, and in the Arduino and C#. I will show you the video. This is the video. This is the code, and this is the video of servo. This is the C#. I've run it, and if I click connect, this is connected to the Arduino is connected to COM6. If I click connect, okay, if I click connect, if I click the turn right, and the servo gonna turn right, turn left, turn left, turn left. Okay, that's the feature that I can show you from an experiment. Thank you so much for your kind attention. See you on the next video.